Hello and welcome to the Let's Talk Azure podcast with your host Sam Foote.
And Alan Armstrong.
If you're new here, we're a pair of Azure and Office 365 focused IT security professionals. Each episode, we talk around a specific topic in the space. This week, it's episode 15 of season 2. We're going to talk around Azure Sphere, Microsoft's solution to an end-to-end secured IoT platform. Hey Alan, how are you doing? Are you excited for Ignite? Is it tomorrow that you fly out?
Hey Sam, I'm doing okay. Yep, flying out tomorrow. So yep, it's gonna be fun, I think.
What are your Ignite predictions? What's your what do you think we're going to see from Ignite? What do you think the focus is going to be on?
So not too. Yeah. I think we're going to see a lot of stuff come out of multi-cloud. Some of the stuff that sort of being in private preview, things like that are now going to come out to GA.
Okay.
And there's definitely some other stuff that I've seen. I'm sure there'll be a product being rebranded somewhere.
Okay.
Um, but yeah.
There always is, isn't there? In it's like that's just normal, isn't it? Right? That's just standard.
Yeah.
Cool. Right. So so this week we're going to be talking around Azure Sphere. Just to give you a bit of context, I'm going to I'm not even going to call myself an expert. I'm the guy Alan is asking questions to. I sort of come from a development background, and I have done work in sort of the IoT space. Not really low level like IoT, like embedded programming or anything like that, but more um, systems that interact with other like IoT systems. And I think Alan and I were talking around a potential IoT project, and I think it was you that mentioned Azure Sphere to me around Microsoft's sort of full ecosystem for secure IoT. And so what I did is I went off and I got myself an Azure Sphere Development Kit. It took ages to arrive. I don't even know where it came from in the end. Um, so I've been playing around with Azure Sphere, and the reason why I did that is because the security model of Azure Sphere is quite unique, I think, and that's why I wanted to talk about it today. I definitely am not an expert in it, that's for sure. So if there are any Azure Sphere experts listening, I apologize profusely for what I'm about to say. But hopefully, what I can do is I can introduce it to you at a high level so that you've got a sort of an understanding of where Azure Sphere might be applicable. If you're it may be in your organization or in your customers' organizations. It is an interesting technology that I think is worth discussing.
Yeah. Okay. So trust you to go and get a device as soon as I mention it. Yeah.
Exactly. Yeah.
Straight in there. Okay. Okay. So Sam, what is Azure Sphere?
Okay. So I think the way that I'm going to approach this is I'm going to talk about sort of more traditional um, IoT IoT devices that you might have, right?
Okay.
Traditionally, the management and the security of IoT devices has been a challenge. I think is a good way to explain it, because you've got lots of different vendors with their own ways of approaching IoT, and different levels of IoT technology, right? You've got some really low level, like I'll call them dumb IoT devices, or you might even want to call them OT devices. And then you've got more sophisticated high level devices that maybe actually do have like full fledged like operating systems on them. Think like a Raspberry Pi or something like that, right? Where effectively, the higher level they are, in some respects, the larger potential attack surface that they have, right? So if you're an organization um, deploying these devices internally, it then shifts to a if we come at it from a security perspective, and that's the sort of arena that Alan and I are focused on. It's around patching those devices. understanding, what software they do have on them, what CVEs they potentially have, and also deployment of applications and things like that can be a real challenge, especially when maybe devices are out in the field, actually deploying new, versioning new applications on IoT devices, especially when you've got multiple vendors at play, can be complex. Um, so enter Azure Sphere. Azure Sphere is an end-to-end IoT platform from silicon all the way to cloud. So, so Microsoft approached this by actually creating their own microcontroller unit. Or I don't know if I don't know if it's in collaboration with somebody else. I don't know that part of it. But effectively, there is a custom microcontroller unit that is um, at its core. Every Azure Sphere enabled device has that chip on it at its core. Now, what that chip is doing is creating a managed environment for you in order to like host and deploy your applications. So I think a good way to explain it is that you effectively use these chips in your devices, and then the management and the security of those devices is completely managed by Microsoft, well, by Azure Sphere, right? So they effectively take away a huge amount of that burden for you. You imagine like OS patching, completely automated, from an Azure Sphere perspective. The operating system itself is completely managed, for you, right? That might also be a hindrance to some people. They might need more flexibility and more granularity. There is a lot of flexibility, and I haven't dived too deep because I'm still in my experimentation and lab sort of stage, right? But what they're effectively doing is they're attempting to build like a walled ecosystem, from end to end, basically around these devices.
So so you talked about it being sort of a chip that you can that's on a board or an IoT device. Um, is is this something you can add to an IoT device, or is something that is basically it comes from the manufacturer in effect with it on?
Yeah, so from it's a completely standalone like ecosystem, I would say, right? It's not something that you can retrofit onto,
Yeah. Okay.
an existing device. Um, uh, the idea is that, like, let's say you're a device IoT device manufacturer, right? Instead of buying your SoC or your microcontrollers from another vendor, you would effectively buy Azure Sphere, enabled ones, from Microsoft's partners, which will give you that end-to-end management capability. And I'll go into how that all sort of functions. But yeah, it is, and that's why originally when I was looking at it, I got slightly confused because when Alan was explaining it to me recently, he's like, so one of the things is that each Azure Sphere device has its own like identifier. Think about it like a MAC address that's baked into the machine, the device basically. Can't be changed, can't be altered. It's part of like the root like trust system. Um, and then you effectively bind it into a special type of tenant called an Azure Sphere tenant. Once it's bound to that tenant, it's in that tenant, as far as I can see, forever, right? Um, so we're really talking around, these devices, aren't designed to be, you know, um, aren't designed to be, resold after the fact or whatever. We're talking about maybe, in devices that may be used internally, or whether you've got a fleet of IoT devices. Maybe you're selling some sort of IoT device that manages something in an environment, and you manage it from a central location. this is going to really help you to do all of that deployment and securing those devices, right? So let's say you're a system integrator and your temperature sensor or whatever it is that you've got, maybe you've got some AI edge like work that you're doing, or something like that. Um, you can help. This can really help you to secure and manage those devices end to end.
Okay, cool. Okay, so what you kind of talked about the security side of things. So what is the security model for Azure Sphere devices? Um, what makes it different?
Okay, yeah. So I have slightly touched on the fact that this is I would say it's sort of its own like independent ecosystem, if that makes sense. But I think with that you do get some like great benefits, right? For a level of if you lose some flexibility in terms of just being able to like buy IoT devices off the shelf, like what am I getting back for my for those problems that I'm maybe facing. So Microsoft talks around the 7 properties of highly secure devices. They've done a white paper on this, and it's really interesting how they've now applied their thinking around this specifically to IoT devices. So the first part of that is a hardware-based root of trust. Okay, so inside of the hardware architecture, there is a root a root core of trust. And that's basically called the Microsoft Pluton security subsystem. So it's in silicon itself, where it actually does. It's the secure root of trust, and it's got the security processing core, cryptographic engines. A secured hardware number generator. It can generate private and public keys, and do all of the security hardware trust aspects of it. So Microsoft have designed that straight into their into the silicon itself, the actual chip itself. There's no separate like TPM module or anything like that. It's all integrated in one place. They also talk about defense in depth. So what we're talking about is providing multiple layers of security and how we harden that. I've talked previously around like your layers of security being like an onion that you sort of peel back, and you have to you work through. Um, so Microsoft build those layers in, and we'll talk a little bit around that when we talk about the actual hardware. But there are multiple layers of defense in there for you as well. Um, they also talk about a small trusted computing base, and this is effectively talking around like on the desktop side we might have user space where like normal user mode applications live. Then you've got say kernel space or a protected space, however your operating system like handles that. What they're talking around here is that your 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 um your trusted computing base, like your kernel space, is as small as possible and completely segregated from your user space, right? So what they're effectively doing is putting up, they call them they call them like IO firewalls in between these different levels. Different applications can only talk to in certain directions and things like that. And completely segregating like the operating system and anything that's got privileged execution. Any trusted computing. Um, they also talk around dynamic compartments, which I've kind of talked about, a bit in the last part, which is around departmentalizing, like compartmentalizing different aspects of your hardware, if that makes sense. I'm going to explain it in hardware architecture, but effectively they slice up the chip into a grid of nine. I think it's nine areas, and they have hardware firewalls in between each one. So only certain areas can talk to other certain areas, dependent on their. So they're really compartmentalizing the silicon and making sandboxed areas. I kind of liken it to and Android, but iOS's security model around sandboxing, and this is way lower level than that, but it's the same sort of idea. Passwordless authentication is another pillar of their 7 properties. So all of this communication is done with signed certificates. From that hardware based root of trust, that's where they're generating these known good and safe cryptographic keys, and being able to do uh, uh, certificate based authentication over TLS, right? So we're talking full, as far as we can say, full end to end encryption right down to the silicon, basically. Error reporting. So we need a way to be able to understand what's happening on these machines, because when we're talking about emerging security attacks, rising rates of errors will usually show anomalous behavior on these devices pretty early on. Sphere devices can automatically report operational data and errors back to cloud-based systems. And then renewable security. So this is effectively Microsoft talking around device software being automatically updated. I will talk about this further in this discussion, but around that there is an end to end, you know, a end to end like operating system like patching ability that requires no intervention from the product manufacturer or even the end user. Updates will be sent to these devices automatically without any intervention. Yeah, which is really powerful.
So, so just not to say recapping, but it it, it kind of sounds like it's the device you connect to the internet, you hook up to that tenant, and the device is secure from start. That's it. There's nothing you have to worry about. It's literally I'm connected
Yeah.
to the cloud and it's already patched itself or it's patching itself, and all I need to do is deploy some applications that will run on it or connect my sensors
Okay.
and things like that.
I'll just explain to you. I was going to go through this later, but it's
Okay.
probably worth doing it now. But I will explain to you what my onboarding process was like. Right, I pulled it out of its box. I had to power it somehow, so I got like I think it's micro USB. So I got a micro USB like power adapter. Um, I plugged it in. I powered it. Oh no, I didn't. No, to start off with, I plugged it straight into my PC. And using there's an add-in for Visual Studio which allows you to manage these devices. I effectively plugged it in. I adopted it using the CLI to my well, I didn't have an Azure Sphere tenant at that point, but now I do. And effectively, as soon as it connected to that, as soon as it was like onboarded, it went fine. I need to do an OS update. It it basically it told me that it needed to do a security update, an OS update. It did that before it just asked me, do you want me to update now, like, and just patch it immediately, which I did, because there are a few warnings about making sure you're patched so you're on the latest. Because I think some of the development kits, the older ones, need like OS patching straight away. And then effectively that was it. It was quite boring, actually. I will actually admit, like it was boringly good. And then at that point, I could configure like Wi-Fi and things like that through like I configured it in Visual Studio, because I'm not in like a deployment setting or anything like that. I'm just actually like deving on it. And that was effectively it. I was ready then to build my to build my applications. And from what I can see, I've had it plugged in for absolutely ages. It just effectively, when there's a new update from Microsoft, it will just effectively just download it like silently. I also don't see any like hiccups in any of my um I haven't seen any hiccups at the moment in any of my data whatsoever. So from what I can tell, it hasn't even rebooted when it's patched. So I don't know how that side of things works. So
It's
yeah,
crazy. So
yeah, it's
that seems really good for an onboarding perspective.
yeah. If you're happy with really buying into the Microsoft ecosystem, and you're willing to go to the level of buying like specific hardware for it, you are going to get a really like white glove experience. And trust me, it is for somebody that's absolutely never used it before. It was, I would say, trivial, like to get it all set up. So yeah, absolutely props to the product team for the onboarding experience. It was very nice.
Okay, great. So take us through the, because you kind of talked about it a little bit, but the hardware architecture then.
Okay, right. So it would be great if I could show you a diagram on a podcast, but I'm not going to be able to do that, so I'm going to have to describe it to you. Um, I misspoke. It's not six. It's not 9 areas. It's actually 6 areas on the chip. I'll just briefly go through each one. You've got the Microsoft Pluton security subsystem. So I've mentioned that previously. It secures the boot process. That's where all your cryptographic generation comes from. It's your secure hardware element of trust. So you've got that one part of it. You've got some flash memory on the chip as well. So being able to actually store, it's usually greater than 16 megabytes, something like that. Um, then you've got your network connection area. So it has got built-in Wi-Fi, which is really nice, to be totally honest with you. And there are a bunch of like breakout boards that you can buy. I couldn't actually get them at the same time. There's like if you've ever used like Pis or Arduinos, there's like hats that you can put on them to add things like WAN and like WAN and like LAN and things like that on top of it. I just simply connected mine to my Wi-Fi and away I sort of went. Now, there's also RAM on there. I believe by default it's got 4 megs of RAM, something like that. Not a lot, but this is a like an edge IoT device. And then the processors are interesting. There's different types of ARM Cortex processors. Um, one's for there's a high level application core, and I'll talk about the difference between high level and real time, high level applications and real time applications. But effectively, the high level applications run like a cut down Linux operating system. So if you can imagine, this might be like a higher level application that's controlling other sub applications. Because what you have is you have these real time cores, and effectively these real time cores um, allow you to run like bare metal code and like real time operating systems on them. So like communicating with peripherals and lower level bits and bobs like that. I didn't get to that point. I just built myself a high level application because that was like the simplest thing to do because I'm not an IoT like hardware programmer, but I really wanted to understand it from the security perspective. So effectively, we've got two different types of cores there that have different functions. Now, I think what's the biggest thing that is important that if you can imagine these 6 areas of the chip, you effectively have firewalls in between these chips, so that certain areas can only talk to other areas. I'll give you the example of the real time cores can only communicate to application cores. Application cores are allowed to connect to the internet, communicate, HTTP, like pushback data. Real-time cores have no network communication whatsoever. The only thing that they can do is communicate back to the application core. So if you imagine you create your high-level application that's sort of your management application of maybe your real-time, devices and sensors that you've got, and then you would pass across those firewalls in the correct way to pass data across. And that's also for attack surface reduction. So your real time, let's say you were controlling let's say you're controlling some sort of like third party like machinery or something with these real time cores, then the only way to talk through to them is through that firewall in the structured way that you've defined. So you're effectively putting up a level of like control with those. I didn't actually go through that. I didn't actually like go through that process of testing that, but that's how I've seen it from like the documentation and the learning that I've basically done.
Okay, great. Thanks. Okay. So how about, the software, the apps that you've been talking about, what can you build on the Azure Sphere device?
Okay, so you do have some options because if you come from like like an Arduino, Raspberry Pi world, you're going to feel very at home in this scenario. And I would say you really do have the benefits of both sides of those. You have your real time cores, which are very much more like Arduino GPIO pins, interfaces in and out. And then you have like sort of your high level application as well, which can do more advanced things like web requests. There's actually like a higher level operating system that runs there. There's an SDK that they've got for interacting with all for those different things. So you can really build sort of like multi. I would say like multi like let's say your application is clustered in the way like you might have different functions. You can run those in different places at the same time and have them communicate back. What I did want to call out is Microsoft's like really great like vertical integration into say things like IoT hubs. For instance, setting up in an IoT hub is again relatively simplistic. You effectively download your tenant, well, your certificate, your Azure Sphere certificate down via the CLI, and then you effectively verify that certificate and create a connection then into IoT hubs. So one thing that's really a challenge with IoT devices is around credential management. Like what credentials do you use on an IoT device and how do you secure those credentials, right? What we're not even doing here is we're not even needing to like even communicate with the devices themselves. All these certificates are generated and handled completely. You effectively run a command line tool to generate, well, to export this certificate for you. You then bring it into Azure Hub, and you effectively, and then you can then add devices in IoT Hub, which will just automatically show. So this is what I did. I effectively exported my certificate, went through a few configuration steps, added my device ID, and then away I was. My device could then communicate. I then push my app to my device to actually see how I would actually communicate up with it, and you effectively, there's no credentials that you need to store or anything like that. You run your application, simple as that. Now you're going to have cost implications of ingesting data into IoT Hub. I totally get that, and if you do have a lot of data that you're pushing back, then that could be costly for you. But for an end-to-end solution, and effectively paying Microsoft to take that pain away from you, I haven't seen anything anywhere near as simple as that, because what effectively will happen when building certain systems, like proof of concepts and dev systems and things like that, it could be very easy to set up these proof of concepts, but when it comes to actually hardening them in production, it can become very, very complicated very quickly when you realize that you don't want like effectively a shared password across all of your IoT devices, and shared credentials being leaked, because it's not like you can just store everything in Key Vault and then pull it down onto these IoT devices. It just doesn't, you don't have like those sorts of protections, right? So I just wanted to call that out because that was a really powerful thing that I saw.
Yeah, it's one of the things, isn't it, that it's secure from start, as I kind of said before, and you don't have to worry about it. Anything you build is code, not necessarily code related, but communication related, and authentication side of things is secure from start, so you don't have to worry about it or remember to add it in
No,
later.
because you've got that hardware like trust module on board, you can effectively communicate via certificates at any time, right? It's there. It's like manage, like we would think about like managed credentials or default credentials inside of like Azure App Service and things like that. It's like it's just there. You can, it's not something that you have to actively manage. I did just want to also call out the Azure Sphere Security Service, and the Azure Sphere Security Service is effectively the thing that is enabling a lot of this, like what you described is this out of the box secure from start like experience, right? And like we'll call it white glove sort of approach. there's three areas of this. There's the passwordless authentication, and we've been a lot on this, so I won't dwell on this. But you know, they they really are getting across the point of we do not have shared access credentials that we are sharing out here. Right? It's all certificate based. So um, if you're not at that point, where you're really, adopting secure certificate based authentication. I mean, a lot of people are. I'm not saying like, it's a proper problem, but this is going to handle a lot of that for you as well. Certificate management on your behalf. Again, some organizations might not like that because, especially when it comes to certificates, some people want to be able to bring their own keys and do all that sort of stuff. So you do have to also, take that into account as well. The Sphere Security Service is also doing the updating. So we've explained the OS applications, but what we haven't also touched on yet, and I haven't actually done this with my device, but I've started to do this is to actually deploy application updates over the air as well. So it's not just software OS updates. I obviously develop with my like SDK box like plugged into my machine, so it's like as fast as possible whilst I'm working with it. But it is also possible to publish your application like catalog for your devices and push it out to them and update them automatically. So no going out into the field to patch devices or anything like that. Um, yeah, that's really powerful. I think one thing that we do have to call out as well, especially when it comes to IoT, you are going to need to have some sort of network connection back to the Azure Sphere service for all of this to function, right? So, because a lot of IoT devices, aren't exposed to public internet, right, or have access to public internet, not exposed onto, but you know what I mean, like have access to the internet. So, you will need to think about your firewalling and how all of this fits together. And then the last part of the Sphere service is error reporting. So this is understanding, crash reporting for deployed software, understanding what's actually going on these devices. There might be a security element to that, but also it's just operational. Like how are things? What's the health of my environment, and things like that. Um, and I think the other part to this is Azure Sphere is built on top of many different other Microsoft technologies like Azure Storage, Cosmos DB, Key Vault, and things like that. And all the data that is stored within Azure Sphere is encrypted at rest. Is I think a big one for organizations nowadays. So from that compliance element, I don't know if you can do customer managed keys and bring your own key and things like that. I would have to go and look at that because that would be if we were talking to a customer about this isn't like a service that we're anywhere near like we would support. It's more of a passion project of mine. But that I could imagine that's a big conversation you'd have with a customer in terms of can I bring my own key? Especially when we're talking about silicon based, you know, um, authorization mechanisms.
Yeah, so I mean, it just it sounds like Microsoft have definitely thought about this, haven't they? About the we keep talking about the end to
Well,
end.
let's hope so, Alan.
Oh, I know, but you know,
Sorry. Yeah.
it's not like it's if you think about some of the Microsoft products have been on a journey, to get to a certain place where it's like matured enough to be good. This kind of feels like it came out and it was I'm gonna say awesome from the start in some sense. Not being in this environment, so it may from my perspective, it sounds really awesome. But
I think they have had to do that. They haven't gone through because like we see some stuff like goes private preview, and you're like, there's so much that is still to be worked on, right? And that's not a criticism. That's just like the world that we live in now, just rapid development over and over again, right? And it
yeah,
doesn't. And when we're talking about certain things, it doesn't matter if there's gaps there, does it? Right? Like in certain especially when you're talking about software, it doesn't matter if it's got gaps, really, because people just might not buy it until those gaps are filled, right? It's like I'm not
hmm
going to opt into that yet, and as soon as it meets my commercial needs and my my values, like the value that I want to gain from it, then I might adopt it. But when we're talking about hardware, like you can't like go private preview on your, your. So I think it's just I personally feel like they've built out all of these things because the investment that they've had to do in hardware and also in terms of operating system updates as well. Like as you imagine, they completely manage the OS
Yeah.
for you, and for customers to adopt that, there has to be a level of trust there that is. I know we trust. I know we trust Microsoft in terms of, like, say, Windows and like Azure and a lot of those things, but this is like these are like relatively new technologies that we're talking about, right?
Mm.
Like, Azure Sphere hasn't been out for that long, right? It's not as battle tested and hardened. Well, I'm not saying it's not hard, like, and it's not hardened whatsoever. But it just hasn't been around for as long, right? So I feel like what they've done, and maybe we've got to Sphere late as well. Like maybe we are. They did go through all those troubles, and maybe they had, like, I don't know because I wasn't part of like any of that sort of stuff. But I do completely agree with you. It's kind of just like appeared out of nowhere, and it seems like really quite mature and thought about. Do you know what I mean?
I,
So it's definitely different.
yeah, I mean, not working in the IoT space, to me, it's kind of like, why wouldn't you? That's the question I've got: is why
Yeah.
wouldn't you do this? Pay,
Yeah.
but
I think it's also a like a last mover advantage as well in some respects. I'm not saying that Microsoft has been slow to adopt this, but I wonder if what they've also done is they've seen what's happened in the IoT space and the problems that their customers have had, and then they've actually gone, no, you know what, we'll actually build something from the ground up that can sort this problem. I mean, adopting this is absolutely massive for organizations, right? You have to buy specific hardware that you're then
mm,
vendor locked into, right? Like it's a big, you know, and especially when you come to actually buying the things, right? They're quite expensive. So yeah, so there's that to think about as well.
okay. So, you kind of talked about it a little bit, but how do you build applications for these devices?
So they've got first party support for, I think, Visual Studio Code and Visual Studio. I didn't use Visual Studio Code because I think I had some problems with it. Might have been me. I think it might have been me. So I used Visual Studio instead. There's like an add-in that you can get, which gives you sort of more management of the device. That effectively allows you to directly like build and side load apps inside of Visual Studio. I basically started from one of their sort of template apps that they provide, and effectively what that does is it pretends that I think it pretends it's a temperature sensor, I think, and it effectively just emits fake temperature readings that it generates like over time. It does some few other things as well, but I'm not capturing that data at the moment. But effectively, what I needed a stream of data that I could then push into IoT Hub to then, process and make sure that things are working. Because I don't I'm not really looking at it from the application side. I'm looking at for management and security and like the hardening aspects, right? Because generally with a technology like this, we might be asked to come in and advise around like the security elements of it instead of the actual applications that are being deployed, right? We might partner with an IoT partner of ours that will handle the on the ground rollout of it and bring that like IoT level of expertise, right? So I didn't particularly care about the the data side of what it was actually pumping out, but I did want to experience that connecting it to IoT Hub, and seeing how what that like implementation plan looks like. And it's pretty simple from my perspective. Not a huge amount to do there, to be honest with
Okay, so you kind of talked about it. We kind of sort of jumped to this, but is there anything else around how it's how it is deployed and the how the management's handled?
Yeah, so like I mentioned, you'll have a completely separate segregated Azure Sphere tenant. It's kind of weird. I've tried to like work out what it is in the portal and things like that. It's not a it's, it shows as a subscription in Azure, but it's not a real one. It doesn't. You try and do things with it, and things get unhappy pretty quickly. The way you also interface with it is effectively all by a command line like program. So you can effectively like onboard devices, and then you can put devices into device groups, and device groups can then have different like application catalogs pushed to them. They can also be subscribed to different operating system feeds. So there's two main feeds, well, two feeds that I'm aware of, which is the retail feed from Microsoft. Effectively, this is like your, your production builds. It's been through evaluation. This is what you want to run in all of your production scenarios. And then there's a retail, it's called retail evaluation, and that is, I think that's like a release candidate. It's distributed 2 weeks before the retail, and that's effectively there to so that you can test. You've got a 2 week window to test device rollouts. So you might want to apply that to a specific set of like test device groups, monitor those, because you are going to get these updates automatically from Microsoft. So you best be ready for them to come in, if that makes sense. Microsoft have got lots of documentation and and guidance around how stringent their backwards compatibility and testing is, in terms of pushing out like updates and things like that. So they're very keen to stress that you know their their main focus is around security, and obviously also rolling out new versions and things like that with new functionality. But they have long supported life cycles and things like that.
Okay. Now the question everyone loves to hear that we always talk about is, how is it licensed? What is the cost?
So a bit weird, this one compared to the rest, is that it's not actually like software licensed. It is all licensed around the actual MCU, so the chips themselves. So there's an MT3620AN chip. That's the one that is like, that's what's used in effectively everything. And what is quite amazing is, if you buy one of these chips, you will get OS and security service updates through to July 2031. They're guaranteeing.
What? Uh,
Yeah. So they're basically saying, they're saying the pricing is less than £8 in our dodgy currency. It's or less than £8.30 is the cost. I don't know if that's like, you're ordering 10, you pay £8.30, then you order 1,000, and it what the trade costs are and things like that. I don't know that. So yeah, and it's it's pretty interesting. And also you get through to July 2031, you get ongoing support for certificate based authentication, failure reporting, and OEM software updates. So the management like service and everything like that, they're basically guaranteeing, if you invest in these chips, that you'll effectively get all of that management completely baked in, you know, as part of it. I mean, yeah, sorry, go on,
no, it's
Al.
good. Just going to go, wow.
well, Sphere is really a gateway to a lot of other Azure services, right? Because what they're effectively hoping is that you're going to pump all of your data into an IoT hub, and hopefully that's a large volume of data, right? Like, that's, let's be honest about it. This is a kind of a gateway product to a lot of other Azure services, but I think they have to offer that level of support and assurance to people, because if you're developing some IoT device, and let's say you build 50,000 of these things, you need to understand that what your ongoing costs for those 50,000 devices. And also, when you're traditionally sourcing for IoT devices, you're not paying any sort of like monthly cost for these chips, are you? Because there's no management.
Yeah, and that's quite a good point actually around that sometimes, yeah, I guess you'd have to pay for services to patch them or to create that VPN connectivity, etc., or whatever that not working in that space. And
Yeah.
just going on the licensing, I think if I remember, it's in effect in the cost of the device, isn't it? It's not you have to buy, you have to put £8
No,
30
no,
on
yeah, that
top.
no,
It's part of
no,
that price, isn't it? You don't actually pay it in
no.
theory.
£8.30 is for the chip,
Yeah,
right? So, you know, like that is the so it's not just the that's not just your like like from how how I understand it, it's that's not the software license or anything like that. That's the chip itself. So you get but I also don't know like what that does to somebody's bill of materials cost. I don't know what a similarly equipped non-sphere
yeah,
device would cost for tray parts. I don't know if that is I don't know if people are paying £2 per chip and actually the £6 uplift is a lot of margin for people to absorb. I can't answer that part of
yeah.
it. I don't
I
know.
th- I think when I was going through this with Microsoft when we were at a session, it was in effect that people are paying a little bit more for it, because they're buying that service in effect. But instead of it being, well, you get for this service, you get for that service, you're basically saying a Sphere device has this service, and you're paying up front for it, and that's it. And you've got patching and all the
Yeah.
management for what 8. It's probably 8 years now. Not it's seven,
Yeah, and
9,
that's
whatever it is.
probably
Yeah.
and that's probably for this version of the chip.
Yes.
When they develop the next version, I'm guessing the cycle for that, would have that. So what they're effectively saying now is that you buy this chip, and until 2031, you're going to be covered at minimum 2031. And we know what happens to Microsoft licensing when there's machines out there in the wild that continue to need like enhanced support like after their end of life, right? So yeah, so I think it's an interesting way to go, but obviously the types of people that are going to buy these are going to be like you know um, device manufacturers and system integrators and things like that, right? You know
Yeah.
that's going to have fleets of different things. So yeah, so any other questions or anything, Alan? That's all I was going to take people through. And I, again, if anybody is out there that's an Azure Sphere, I call them an administrator and developer. I completely apologize if I've butchered anything or missed anything like absolutely massive from it. But that's my experience so far. Maybe we'll do another wrap up. We'll do another episode on it once I've got a little bit more experience on it or something like that. But anything else that you want to understand, Alan?
No, I think you've covered it quite well in the 47, 48 minutes. Um, I think I'll do a quick reflection to see if I've captured some of it. I kind of did a little bit of that along the way, but let's see what we've got at the end here. So, yeah, the Azure Sphere devices, that from end to end, silicon to cloud, IoT deployment, and security solution. So, it is you don't have to worry about that communication whatsoever. Um, it's a custom silicon with firewalled architecture to limit different applications or different processes running on that application, um, accessing different resources on that chip. Um, as we keep talking about, automatic patching, and for for this current chip, for 8, 9 years at the moment, and it's all that's included in the price of the device. All this communication, VPNing, etc. All that communication's all done for you. And then, inbuilt application and device deployment service. So it's built into Visual Studio, so you can build your apps and things like that for it. Is that about right?
Yeah, that's it. Yeah, yeah, and I think I think as we've explained, if you want a really well integrated like walled ecosystem for your IoT devices, Azure Sphere does have a lot of very interesting and different ways to approach IoT, for sure. Alan, what's our next episode? What we're going to be talking about next?
So I think we've kept mentioning it in various episodes, but never actually done an episode in it, which I'm surprised about, considering it's basically my life quite a lot of the time. But Microsoft Sentinel, cloud scene, Microsoft's version of it, and SOAR technology. We're going to talk about its capability.
Okay, great. Yeah, like you say, I can't believe we haven't done
No.
Sentinel. And when we were like deciding through what we were going to talk about, it was like, why haven't we talked about that already? That seems mental that it wasn't one of the episodes so far. So yeah, Alan's going to take us through an overview of Sentinel, which will be great. If you've enjoyed this episode, please do consider subscribing if you'd like to listen to more of this sort of content in the future. We have many topics that we'd like to cover, and your listens and support is what will continue to fuel the podcast going forward.
We also have the ability for you to give us some feedback. Did you enjoy this episode? Disagree with our thoughts, or even did we miss something completely? Um, Please use the form that's in the show notes to send us a message. We'd love to hear from you.
Perfect. Thanks everybody for listening. If you've made it this far, and Alan, I'll catch you on the next one. Cheers.
Yep. Thanks everyone for listening. Take care. See ya.